Right. Good evening. So first of all, if you are watching a video, so make sure you are watching a full video, right? Make sure you are watching a full video, right? So then, so today our plan is first part is atomic orbitals, right? Atomic orbitals, and then we talk about the most important part, one of the most important part in the first lesson, which is electron configuration, right? uh, you're already familiar with electron configuration, but here we just talk it very deep, right? Deeply. So first let's finish this part, atomic orbitals, right? Atomic orbitals. So Lamai, what is this concept? Previously we said electrons rotating around the nucleus, right? So that's what we learned, right? Then again, last week we said it has subshells and those things, right? The main shell, and then there's some subshells, right? So in your mind you have an idea it's rotating, right? Like a planet rotate around the sun, right? But then the reality, it's not like that, right? It's not like planets, right? This electron, further, when after they studied further, right? So they found out there is a specific area in the atom. These specific atoms exist, right? These atoms, let's say you want to find that atom, right? So it's not rotating around this specific orbital, right? There is a specific area in the atom that electron is existing, right? So in other hand, you can say that the probability, right? Probability of the electron, right? It's existing in a specific area. That area has this specific shape, right? That's what we're talking about here, right? That's what we're talking, right? So that's the basic idea, right? So then each orbital has a specific shape, right? Here, in your level, we only talk about s orbital and p orbital, but each orbital, d orbital also have a different shape, right? So, so write down the main topic, atomic orbitals, and then subtopic s orbitals, right? First one, s orbital. Right. Just get the idea. This is about, these shapes formed by analyzing the possible areas, possible area that electron can found or electron can exist, that is specific electron, right? There's a specific area for specific electron, right? It should be there, right? So one electron in s orbital, that there is a specific shape for s orbital, right? So it should be there, right? It can't be somewhere else. ඒ shape එකේ තියෙන shape එක කියලා කියන්නේ that is specific area, right? ඒ area එක අපි analyze කරාම it has a specific shape, right? එයා ඉන්න පුළුවන් area එකේ shape එක තමයි කියන්නේ, right? නැතු electron එක shape එකක් ගන්නවොත් මොකක්ද බයිලයක් නෙමෙයි, right? Write down according to the knowledge we have now, an electron can be found anywhere. An electron can be found anywhere. An electron can be found anywhere. An electron can be found anywhere around the nucleus. Electron can be found anywhere around the nucleus. Can be found anywhere around the nucleus. Yes, but most of the time, but most of the time, most of the time, it is quite close to the nucleus. It is quite close to the nucleus. Right, this is probability. We call radial probability. It's one distance from nucleus. Right, so there is a specific area that has highest probability, right? So we consider about that area, right? That means, I mean, if you mark the, so this, let's say this is nucleus, right? So if you mark the electrons that you can, I mean, if you mark the places that you can find the same electron, right, in an s orbital, in a s orbital. So if you mark that places you found that electron, what did you do? You just marking the electron. This is one electron, na? Here you are marking the places that you can find that electron. So you will get this kind of shape, right? I mean, you may mark some other places also, but mainly it's like this, the basic area, right? So therefore we call this shape, right? We take this shape as a shape of s orbital, right? So that's how these shapes form, right? So write down these two diagrams, right? I'll show a colored diagram. Give me a second. Right, can you see this diagram? Right, so here it's explained the same thing, right? So here this is the darker part means higher electron density, right? The lighter means electron density means the probable places, right? Probable area, right? Where you can find electron, right? So that's the idea. Okay. So here distance from nucleus, right? I mean theoretically, you can argue, it can be anywhere, right? But these are the possible places. There is area, it's mainly lying, right? So mainly existing. So therefore that shape is spherical shape. Therefore we said the shape of the SC is spherical like this. Just get the idea how do we make these shapes, right? Otherwise you may think something different thing, huh? Right, so the idea when it's become bigger, higher, the second energy level S orbital is bigger, right? It's bigger. Third energy level S orbital is more bigger, right? Clear? It's expanding. Write down. Write down. This figure shows. This figure shows. This figure shows the distribution of electron density. This figure shows the distribution of electron density. The distribution of electron density. The distribution of electron density. Electron density in a hydrogen. In a hydrogen 1s orbital. In a hydrogen 1s orbital. Right. The 90% probability of the 90% of probability the 90% of the probability of the electron exists within a sphere. Exist within a sphere. Exist within a sphere. Exist within a sphere. Sphere. Right. Next point. All s orbitals are spherical shape. 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 All s orbitals are spherical shape, but differ in size. But differ in size. So, if this is 1s, this one, and this one, 1s, 2s, 3s, right? Draw the diagram. Right? Depend on the size. Right. Then write down p orbitals. Next one, p orbitals. Right, p orbitals. When we come to p orbitals, the possible, when we mark the, when we consider the most possible area that electrons exist, the shape like dumbbells, right? Like a normal dumbbell, I mean, something like this, kind of bigger infinite mark, right? I mean, this is like two balloons combining together, right? Like combining two balloons. Okay. So as you know, how many orbitals? How many p orbitals? There are three p orbitals, right? How many p orbitals? There are three p orbitals. So then this is one, right? How these three orbitals lie then, right? These three orbitals exist like, I mean, one like in x-axis, you know x-axis, right? This is y-axis, this is x-axis, xy, right? Dimensions, right? X dimension, y dimension, right? And then there's another dimension, right? I mean, third dimension, right? Z, right? So these p orbitals lie in those three dimensions. Another one lie in y-axis. Another one in Z. Z means through the board. These two are in the board, right? This one through the board. So write down. So we name them as 2px, 2py. I mean, this is example. I mean, px, py, px, py, p is it right? Here we consider 2p orbitals, right? So therefore, you can write something like this. Write down. There are 3p orbitals. There are 3p orbitals. There are 3p orbitals. There are 3p orbitals considered there are 3p orbitals. Consider n equals to l equals 1. N equals 1. Write down 2px, 2py, 2pz, right? So remember, the only difference is the arrangement, right? The only difference is arrangement. That's it. The difference is arrangement. That's it. Nothing else. Size also similar. If it's in the same if it's in the same energy level, I mean main energy level, the size is similar, right? They are similar in size. So write down. They are identical in size, shape, and energy. They are identical in size, shape, and energy. Underline size, shape, and size. Underline size, shape, size, shape and energy. Size, shape and energy. Okay. Then next point, they only differ from orientation. 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 So draw the diagram. Draw the diagram. Write down. Write down main topic. Right, it's over now. Right, so that's it. So remember the shape. Write down. Let me show a diagram. Look at this. It's arranged like this. Right. This one D, right? I mean, it's not in your syllabus. Right? This is D. It also have a shape. Right. Write down a main topic. Electron configurations. Electron configurations. What is electron configuration? You learn it in all levels, right? What did we do on the electron configuration? We express the electrons distribution, right? We express the electron distribution throughout the orbitals or energy levels. So that's what we did, ne? So same here, right? Same here. We're gonna express the electrons, the positions of electrons throughout the, electron distribution throughout the energy levels or orbitals, right? But not like always here we have to consider, the suborbitals and the sub-energy levels, those things, right? So write down a sentence under electron configuration, right? Topic electron configuration. Electron configuration. Write down the way electrons are distributed. The way electrons are distributed. The way electrons are distributed among the way electrons are distributed among the various orbitals. Among the various orbitals. Among the various orbitals. Among the various orbitals of an atom. various orbitals of an atom is called the electron configuration. Is called the electron configuration. Is called the electron configuration. Right. So the basically how these electrons fill, right? So here we are talking about the filling electrons, right? Distribution means we have filled electrons, right? The basic principle behind of that, I mean the very basic one, the energy, right? Right? It's fill according to the energy increasing, right? According to the energy, right? I mean, low energy to higher energy, right? Higher energy orbitals, right? Write down. That's the basic principle, right? It's filling according to the energy, right? Increasing energy, right? It likes to stay in low energy, right? First fill lower energy levels and then higher, lower to higher. Write down. The orbitals are filled. The orbitals are filled in order to. The orbitals are filled in order to. in order of filled in order of increasing energy. The orbitals are filled in order of increasing energy. In order of increasing energy. Increasing energy with no more than two electrons, no more than 2 electrons per orbital, no more than 2 electrons per orbital, right? So we learn it in previous lesson we talked about that, right? One orbital can keep 2 electrons, right? අපි කලින් කතා කරා. And those electrons act opposite directions, right? අපි plus we put plus minus plus half minus half මතකනේ plus half we did that, right? If there are two, it's act oppositely, right? Opposite direction, right? Third, basically so how do we represent it, right? Let's say lithium, right? So we just fill the orbitals. That's what we do, right? So lithium has 3 electrons. So definitely, I mean, the first 2 electrons goes to first energy level, right? First energy level only contain 1 s orbital, right? So therefore, we mention 1 means the energy level, right? The first letter mention energy level, and then second one it's orbital. Here the number of electrons, right? Number of electrons, right? Here energy level, this one orbital, then number of electrons, right? Then 1s2, then 3s1. So this is the simple way we fill it electron. Though there is a thing called orbital diagram. We mention the orbital using a square, right? This is called orbital diagram. The 1 square means 1 orbital. This is orbital diagram, right? 1s, 2s, 1, and 1s and 2s, right? That's the orbital, exact orbital. Okay, just write down a sentence. We can represent electron configuration. We can represent electron configuration. We can represent electron configuration. We can represent electron configuration we can represent electron configuration by writing the symbol by writing the symbol by writing the symbol by writing the symbol for the occupied subshell for the occupied subshell for the occupied subshell and writing symbol for the occupied subshell and adding superscript adding superscript adding superscript adding superscript adding superscript to indicate the number of electrons superscript to indicate the number of electrons adding superscript to indicate the number of electrons in the subshell number of electrons in the subshell. Right. So then draw the diagram, right? The whole one, right? This is orbital diagram. Draw the both. After that, we have to talk about some principles that require to write electron configuration, right? We should know these basics. Finish, ne? Right. Then let me write down. There are few rules and principles. First one, Pauli exclusion. Pauli exclusion principle. Right? Write down the topic, Pauli exclusion principle. Right? So this basically this theory explain. Actually, I already said that, right? So this theory explain. One thing is know any electron, I mean both, basically it's quantum numbers, right? One thing about quantum numbers, right? So only one, only specific set of quantum numbers should have only for one electron, right? Two electrons can't keep same set of quantum numbers, and when electrons exist, when two electrons exist in one orbital, they should rotate oppositely, right? They should rotate oppositely, and we should mention it like this, right? Opposite directions, right? That's the basic idea, nothing else. Okay. And it says, one orbital can hold only two electrons also. So write down, let's finish this quickly. it explained it explained no two electrons in an atom. It explained no two electrons in an atom. No two electrons in an atom. No two electrons in an atom. No two electrons in an atom can have the same set of same set of four quantum numbers. Same set of quantum numbers. Next point. Electrons in an one orbital. 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 Electrons in an one orbital can have two ms values. 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 Continue. This indicates this indicates that an orbital can hold a maximum two electrons. 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 And and they must have opposite spins. They must have opposite spins. They must have opposite spins. Okay. This is the next pevunne. Right. Right. Then the next rule. So what is Pauli exclusion principle? Only two electrons, and it should be opposite spins, right? And there's no any same quantum numbers for two electrons, right? Even in the same orbital, they should have different ms values, right? Plus minus, half plus minus. Right. Then next one, Hund's rule. Hund. Next one, Hund. Hund's rule. Hund's rule. What Hund said? Huh? Hund said, Hund said something like this, I mean. Give me a second. Right. Here, Hund said, when these electrons filling, right? When these electrons filling, when there are, I mean, same, let's say P has three orbitals, right? So when they filling, these electrons fill first, I mean, same spin, right? These electrons fill in same spin. It's like, I mean, just let's say in a bus, right? The way people sitting on a bus, right? Let's say there are 10 seats, right? 10 seats. I mean, so there are some, I mean, full empty, I mean, let's say 5 full empty seats and 5 half filled empty seats, right? So which seat would you choose to sit, right? ඔයා මොන වගේ සීට් එකකද ඉඳගන්නේ බස් එකට ගියාම ඒ වගේ තියෙද්දි බස් එකේ දැන් සීට් එකේ දැන් 10ක් සීට් 10ක් තියෙනවා 10න් දෙන්න ඉන්න පුළුවන් දැන් පහක තනියෙන් ඉන්නවා ඉතුරු පහ එම්ටි ඔයා මොන සීට් එකේ ඉඳගන්නේ right දැන් මෙතන හුන් රූල් එකෙන් කියන්නේ නිකන් දැන් අර බස් එකක යද්දී මේ ඒ හිතන්නකෝ සීට්ස් වල දැන් සීට්ස් තියෙනවා 10ක් right there are 10 seats and then 5 seats occupied by single person right one seat can I mean the single seat yeah, sorry double seats right I mean right 2 seats right so let's say 4 seats right so this one is occupied but this part is empty right this one is occupied right just a single bus right right so which one you will choose ඔයා මොන සීට් එකේද ඉඳගන්නේ දැන් මේකේ බස් එකේ මේ දෙපැත්තේ මේ තනි සීට් නේ තනි සීට් කියමුකෝ මේ තනි සීට් එකක් කියමුකෝ මේක දෙන්නෙත් ඉන්න පුළුවන් right බස් එකේ සීට් එකේ දෙන්නෙත් ඉන්න පුළුවන් එතකොට දැන් 10 දෙනෙක් සීට් 10 there are 10 seats right so there's 5 people sitting on single seats right so there are 5 completely empty seats right 5 completely empty seats right completely empty like this one right 5 completely empty seats right මේ මැද්දෙන් යනවා දැන් හරිද මැද්දෙන් යනවා which seat would you choose a seat that already occupied by someone I mean the half filled right half filled seat or completely empty seat which one would you choose that's what I am asking generally මෙතන නිකන් අර ලස්සන කෙල්ලෙක් හරි මොකෙක් හරිවත් නැත්තම් මොකද්ද මොන සීට් එකේද ඉඳගන්නේ හරි නිකන් කෙල්ලෙක් හරි නිකන් නේ කවුද නිකන් අක්කෙක් හරි කවුරුවත් නැත්තම් මේ තනි එක තමයි ඉඳගන්නේ සාමාන්‍යයෙන් අපිට මොකා හිටියත් තනි එකේ ඉඳගන්නේ හරි මේ that's how electrons also work, right? So they like to stay single. They like to stay single, right? Like, I mean, as we like to stay in a single seat, I mean one seat, right? Empty seat. Empty seat එකේ අපි ඉන්න කැමති වගේ තමයි. මෙයාලත් කැමති අර empty එකකට ring ගන්න, right? So that's what Hunds explain, right? Hunds කිව්වේ okay. They like to keep same spin, and then there is this extra stability of half filled and fully filled orbitals, right? There is a extra stability of an half filled and fully filled orbitals. This one has a stability. Then the fully filled one, that one also is stable, right? This one also have extra stability, right? Hun said that thing, right? So what Pauli said, he said there's only, I mean, same quantum numbers can take by one electron, and when there are two electrons in same orbital, they should spin opposite directions, right? So that's what Pauli said, right? Pauli කිව්වේ ඒක. Right. Then okay, let's write down a little bit. Right. Write down Hund's rule. It explained the lowest energy is attained. The lowest energy is attained. It explained the lowest energy is attained when the number of electrons having the same spin, is maximized. Same spin is maximized. Next point. This means that electrons occupy orbitals. Singularly to the maximum extent possible. 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 And to the maximum extent possible, and that these single electrons in a given subshell all have the same spin. All have the same spin. Subshell all have the same spin. All have the same spin. Magnetic quantum number. all have the same spin magnetic quantum number. All have the same spin magnetic quantum number. Same spin magnetic quantum number. Right? Next point. Draw this diagram. This one. When this is the possible one, right? Then this one is not possible, right? This is not the arrange. This is not the way they arrange. This one wrong. Right. After filling like this, the next electron goes to next electron goes to next electron right. Draw it. Write down the last point. Write down the last point. Right. Write down. Next one. Next sentence. Fully filled subshells. Fully filled subshells. Fully filled subshells are stable than. Fully filled subshells are stable than. Fully filled subshells are stable than half filled subshells. Fully filled subshells are stable than half filled subshells. Fully filled subshells are stable than half filled subshells. Right. Then next principle, which is called Aufbau principle. Aufbau principle. Right. Aufbau principle. This one explain specific shape of electron filling, right? ඒතර මෙයා අර ෆිල් වෙන මෙතඩ් එක මෙයා තමයි එක්ස්ප්ලেইন කරේ. කොහොමද ෆිල් වෙන්නේ කියන්නේ අර අපි හිතන විදිහට එහෙම ෆිල් වෙන්නේ නැහැ මේක, right? සෝරි මේ මෙතන මම 3s කියලා දාලා තියෙනවා. right. එතකොට මේකේ අර දැන් සමහර තැන්වල 3D 4S එක කලින් ෆිල් වෙනවා. අන්න ඒ වගේ කතන්දර තියෙනවා. ඒතකොට ඒ ඔක්කොම ඩීටේල්ස් ටික මෙයාගේ අවුට්බාව් ප්‍රින්සිපල් එකෙන් තමයි එක්ස්ප්ලেইন කරන්නේ. right. ඒතකොට ඒකේ ඩයග්‍රෑම් එකක් තියෙනවා. අපි චුට්ටක් සෙන්ටෙන්ස් එකක් ලියා ගමු. ලියලා ඩයග්‍රෑම් එක අඳිමු. The filling of electrons, the filling of electrons, the filling of electrons, the filling of electrons, the filling of electrons in an atom, in an atom, in an atom, in an atom begins with, in an atom begins with subshell, with subshell that has lowest energy, that has lowest energy and continues upward according to the continues upward according to the Aufbau principle, right? According to the Aufbau principle, right? මේකේ ඩයග්‍රෑම් එක අඳිමු. ඩයග්‍රෑම් එක කියන්නේ මේකේ මේ මෙතඩ් එකක් තියෙන ෆිල් වෙන. මේක අර මෙහෙම මේක මතක තියාගන්නවක්වත් ඕනේ නැහැ. මම මේකට ෂෝට් රූට් තියෙනවා ඒකත් පස්සේ කියන්නම්. right. 2p 3p 4p 5p 6p 7p, 3d, 4d, 5d, 6d, 7d, then 4f, 5f. හරි මේක එතකොට ෆිල් වෙන්න ළමයි මේ මෙහෙම. මේකත් මෙහෙම යනවා. ඊට පස්සේ يعني මේක ෆිල් වුණා ඊට පස්සේ 2s ෆිල් වුණා ඊට පස්සේ මෙහෙම 2p 3s ඊට පස්සේ 3p වලට පස්සේ 4s 4s يعني 3d ෆිල් වෙන්නේ නැතුව 4s වලට යනවා. ඊට මේක මෙහෙම ඊට පස්සේ මෙන්න මෙහෙම ඊට පස්සේ මෙන්න මේ සෙට් එක මම මේක ඩයග්‍රෑම් එක ඩිස්ප්ලේ කරන්න ඒක ලේසි වෙයි. ඊට පස්සේ ඊට පස්සේ 70 copy this diagram. මගේ එකම තමයිනේ. හරි රයිට් මේ කොපි කරගන්න ටක් ගාලා. ඕක තමයි ඔක බිල් වෙන මෙතඩ් එක. Right. Then I will draw the energy diagram, right? I mean orbitals, right? I mean how these orbitals change. First orbital, it's 1s, right? This is energy, right? This is 4p, right? So write down general energy ordering of orbitals. General energy ordering of orbitals, and then mention it, right? This is general energy ordering. General energy ordering of orbitals, right? So mention it. මේක මෙයා ඉඩ තියෙන විදිහත් එක්ක මෙයා දාලා තියෙන මේක උනත් තවර අස් කරලා ඉඳයි බලමු මේක ඩයග්‍රෑම් එකක් තිබ්බොත් මම ඩිස්ප්ලේ කරන්න. ළමයි ඔක ඩ්‍රෝ කරගන්න. right ළමයි මේක දාගන්න. කොහොම කොපි කරත් කමන්නේ. Right. Then right. We then write down a small topic: electron configuration of several elements. Electron configuration of several elements. Electron configuration of several elements. Right. එතකොට මේක බේසික් සෙට් එකක් අපි කතා කරගෙන යමු. එක්සැම්පල් එක. element electrons electron configuration. Right, first one start from beryllium, right? Electrons for electrons, orbitals ටික අඳිමු. 1s 2s අපිට orbitals වල නම් තියෙනවා. orbitals වල ටික ලොක් කරමු. electron na. Four electrons, then 1s 2s 2p 3s, right? 1s 2s 2p 3s. So first then fill වෙද්දි හොඳට මතක තියාගන්න. First it filled first energy level, then it's filled second energy level, right? Then it goes to second energy level, right? In second energy level, I mean, again, from second energy level, it has several orbitals. So it's filled one orbit, right? One, I mean, one sub energy level, right? One sub energy level, and then goes to the next one, right? So when there are several orbitals that has same energy, when there are several orbitals that has same energy, what will happen? It's just sitting like, I mean, empty seats in the bus, right? අර බස් එකේ ඉඳ ගන්නවා වගේ තමයි ඉලෙක්ට්‍රෝන්ස් ටික ෆිල් වෙන්නේ, right? ඕබිටල්ස් කීපයක් තියෙද්දි, right? එක ඕබිටල් එකකට ෆිල් වෙද්දි ඒ සබ් එනර්ජි ලෙවල් එකේ ඒක ෆිල් වෙනවා, right? එතන මේක ෆිල් වෙනවා ඉතින් මේක කතා කරද්දී. It's a beryllium. මේක ෆිල් වුණා, then it jumps to 2p. දැන් මේක ෆිල් වුණා 2p 2s field. මේකෙදි සෙකන්ඩ් එක යන්නේ මේකට, right? සෝඩියම් වලට එද්දි 11. ඒක ෆිල් වෙලා ඊට පස්සේ මේවා ෆිල් වෙලා it goes to 3s, right? ඔතත් පස්සේ 3s එකට යනවා. ඊට පස්සේ ඉලෙක්ට්‍රෝන කන්ෆිගරේෂන් එකක් ලියමු. ඒක ඉලෙක්ට්‍රෝන කන්ෆිගරේෂන් එක කොහොමද එන්නේ? 1s2 2s2 1s2 2s2. ඒතර මේ මෙව එක ලියද්දි මේක විතර 3p1. ඒ එක සෙට් එකක් එකට ලියන්නේ. ඒක ලොකු ස්පේස් එකක් තියන්නේ මැද්දේ. 1s2 2s2 3p2 1s2 2s2 3p6, sorry, 3 trillion 2p 2 it was 3p1, sorry 3s1, right? ඔහොම තමයි එන්නේ ඔය සෙට් එක. මහසින් නෑ නිකම්ම ෆිල් කරගෙන යන්න තියෙන. ඔක අර එක්සෙප්ෂන්ස් එනවා, අපි ඒක කතා කරමු. ඊට පස්සේ අපි මේකේ එක්සෙප්ෂන්ස් එන්නේ ඇත්තටම D බ්ලොක් එකට යද්දී, right? ඉතුරු සෙට් එක ඔය විදිහට මේ ෆිල් වීගෙන යනවා. එතකොට ඔයාලා තනියෙන් ලියන්න අපි මැද්දෙන් ගමු. ඔයාලා මෙන්න මේ සෙට් එකට ලියාගෙන යන්න මේ පැටර්න් එකට. උතන ෆිල් වෙද්දී වෙනසක් එන්නේ potassium ඉඳන් right මෙන්න මෙතන potassium ඊට පස්සේ calcium D block එකට දැන් ඔයාලට මතකද දන්නේ අර මේ මෙතන අර O level කාලේ තිබ්බ මේ වෙනසකුත් කියන්නම් O levels වලදී මතකද අර මේ the way it's filled in O levels you wrote in electron configuration of potassium and calcium like 2 8 8 1 and 2 8 8 2 but again you learn third energy level can keep even in O levels you learn third energy level can keep 16 electrons then why didn't you write like this and this one 10 the reason now you learn the reason now you're going to learn the reason is sub energy levels right 4s orbitals filled early than so this is fourth energy level right so fourth energy level filled earlier than I mean 4s right 4s orbital filled earlier than 3d right එතකොට ඒකයි මෙතන ෆිල් වෙලා මෙතන 2 වෙලා ඊට පස්සේ ෆිල් වෙන ටික මේකට කියන්නේ right හොඳට ඒක මතක තියාගන්න O level කාලේ ඔයාලා නිකන් ඩවුට් එකක් වගේ තිබ්බනම් ඒක තමයි කේස් එකේ තියෙන්නේ right so ලියාගෙන යන්න මේ සෙට් එකට potassium calcium scandium titanium indium chromium හරි මෙන්න මෙතෙන්ට ලියන්නකො ඔය සෙට් එක ලියාගෙන යන්න ඒතර මේක ලියද්දි 1s2 2s2 2p6 3s2 3p6 4s1 then 10 1s2 2s2 2p6 3s2 3p6 4s2 ඊට පස්සේ මෙතන ඉඳන් 1s2 2s2 2p6 3s2 3p6 3d1 4s2 ඔන්න ඔතන ඉඳන් පටන් ගත්තා ඊට 1s2 2s2 2p6 3s2 3p6 3d2 4s2 ඊට පස්සේ 1s2 2s2 2p6 3s2 3p6 3d3 4s2 right clear නේද ඒ ටික? නිකම්ම D block එක මෙතන ඉඳන් D block එකට එනවා. right? මෙන්න මෙතන ඉඳන්. ඊට පස්සේ chromium ගින්දලා චුට්ටක් මොන කතාව වෙනස් වෙන තැනක් එනවා. අවුෆ් බාව පොඩ්ඩක් විතර පයින් තැනක් එනවා. chromium ගින්දන් චුට්ටක් ඒක බලමු. ඔය ටික normal ම fill කර හැකි. පුත් වෙනසක් නැහැ. ඊට පස්සේ chromium ගමු. chromium ගෙත් ලියමු 1s2 2s2 2p6 මදිද නේද? කොරන්ටම ගමු. chromium 1s2 2s2 2p6 3s2 3p6 4s2 3d4 නේ. ඔහොමනේ දෙන්නේ. මෙතන 3 ඊට පස්සේ 4 නේ. මෙන්න මෙතන එක්සෙප්ෂන් එකක් වෙනවා. මොකද වෙන්නේ? fully free, I mean half filled d orbitals have extra stability. Half filled d orbitals have an extra stability. Therefore, what will happen? One electron jumps to d orbital. එතකොට මේක මෙහෙම ලියන්නේ නැහැ. මොකද ලියන්නේ? මේක ලියන්නේ d5 1s. right. මේකට යටින් පොඩ්ඩක් sentence එකක් දාගමු. Write down elements with completely filled or elements with completely filled or half filled elements with completely filled or half filled d sub energy level are relatively stable relatively stable therefore it's rearranged therefore it's rearranged as follows, right? So we're d 3d 4 4s මෙන්න මෙන්ෂන් කරන්න 4s 2 එක rearrange වෙනවා 3d 5 4s 1 වලට ආයේ 3d 9 4s 2 rearrange වෙනවා 3d 10 4s 1 වලට එන්න කොපවලත් ලියන්න. Therefore Cu 1s2 2s2 අනිත් ටික normal යනවා 2p6 3x2 3p6 3d10 4s1. තව ස්ට්‍රා එකක් දාලා ලියා ගන්න. තව ස්ට්‍රා එකක් දාලා ලියා ගන්න. Configurations ending with නෑ එහෙම ඕනේ නැහැ. අපි අර කලින් කතාව තමයි එහෙම ලියමුකෝ. Completely filled or half filled configurations are relatively stable. Right? Completely filled or half filled configurations are relatively stable. Therefore, S2, S6, D10 are more stable. Right? D10 are more stable. ඒක රතනත් මම කලින් කිව්වනේ. ඊට පස්සේ මේ අර තව ටිකක් දරුණු එක්සෙප්ෂන්ස් කීපයක් තියෙනවා. ඒවට යන්න කලින් පොඩි චූට්ටක් ලියන්න. condense electron configuration. Condense electron configuration. Condense electron configuration. දැන් මේක අර ලියලා ප්‍රැක්ටිස් කරානේ. ලියන්නකො condense electron configuration. ළමයි condense electron configuration means දැන් ඔය Google එහෙම කරලා බලන්න. ඔය 11 එකක් Google කරාම එහෙම ඕක දෙන්නේ ඔය ෆුල් එක පත හැල්ලම ලියන්නේ නැහැ. හරිද? ඔක පත හැල්ලම ලියන්නේ නැහැ. ඒ වෙනුවට we use the closest noble gas as a configuration. Example, let's say which one example? Take lithium, right? Lithium we should write 1s2 2s1, right? So you can write this in condensed form. So 1s2 means what? What is this which electron has this configuration? Helium. So then you can write helium and then 2s1, right? Then helium represent this the front configuration, right? Another example, let's take sodium. This is very easy. Sodium 1s2 2s2 3p6 sorry 2p6 3s1. Then you can replace it. So this configuration, what is this configuration? This is, sorry, not helium, I mean neon, right? This is neon. So then Ne 3s1. Right? This is very easy. Write down the electron configuration. Write this sentence and then, after that, use this condensed form. No need to write the full form. The electron configuration of nearest noble gas element. The electron configuration of the nearest noble gas the electron configuration of the nearest noble gas element the electron configuration of the nearest noble gas element of the lower atomic number noble gas element of lower atomic number is represented is represented is represented is represented by is represented by is represented by its chemical symbol represented by its chemical symbol in brackets is known as condensed electron configuration. Write this example. Right. මේකේම ෂෝට් කරලා ලියනවා මේ ළඟම තියෙන configuration එක ගන්න. දැන් copper වලට ලියනවා නම් copper වලට ලියමු. මෙතන ළඟම ඉන්න එක්කෙනා කවුද? ආගන්. ආගන් කියන පටන් ගන්නවා. ආගන් දාන්න මේ සෙට් එකම අල්ලලා. AR. හරි. ඒතකොට AR නිකන් මෙතන D10. AR bracket 3D10 4S1. මේ අපි කතා කරොත් මෙතන ඩිෆරන්ස් එක විතරක් නෙවෙයි තව කුණුහරුප වගේ ඩිෆරන්සස් වෙනවා වගේ. අපි සිලබස් එකේ ඔය 54 first 54 කියලා තියෙන්නේ. 54 කියන්නේ up to xenon නේ. ඒතකොට ඔය අර ඔකේ d orbitals වල second sorry මේ කියන්නේ d කියන්නේ second d set එකේ right. මේ සෙට් එක ඇවිල්ලා ක්‍රෝමියම් එකේ තියෙන ෆස්ට් D සෙට් එකනේ. ඊට පස්සේ ඕකට පල්ලෙහා සෙට් එකේ අමුතු ඒවා වෙන්නේ. හරි. ඊට පස්සේ මම පෙන්නන ඒවා ලොකුට රීසන්ස් අනම් මනන්නේ මේක අර පැලේඩියම් ගැන චූට්ටක් දාගමු. පැලේඩියම් වල වෙන වෙනස අනිත් ඒවාගෙත් මේ වගේ වෙනස්කම් තියෙනවා right. නෝමල් විදිහට ස්ට්‍රේට් ලියන්නේ නැහැ. මේක විතරක් නෙවෙයි තියෙන්නේ right. ෆස්ට් එකේ ඕක විතරයි තියෙන්නේ. අනිත් ඒවාගේ වෙන නිකන් හරි කිස්වල තියෙන හරි. දාගමුකෝ. දැන් පැලේඩියම් ගත්තාම කියන්න කලින් මේක වෙන වැඩේ කතා කරමු. පැලේඩියම් ගත්තාම දැන් මේක අපි නෝමල් වෙන්නේ KR 5S 2 4D 8 පොඩ්ඩක් ඉන්න. මේක අපි මේ ලිව්වා මේක දැන් මෙතන ඇතුලෙන් දාලා මෙහෙම ලියන්න කමන්න බෑ මෙහෙම තියන්න 48 ක් විතර. ඒතර ඕකේ දැන් රියල් ෆෝම් එක ඕක ඇත්තට තියෙන්නේ KR 4010 ඔහොම. ඒ කියන්නේ මේ දෙකත් මෙතෙන්ට පැනලා. හරි. ඒකට ඒකෙන් එක්ස්ට්‍රා ස්ටැබිලිටි එකක් එනවා. ඒගොල්ලෝ එක්ස්ට්‍රා ස්ටැබිලිටි එකක් එන විදිහට ඔහේ මාරු වෙනවා. අර දැන් අවුට් බව් එකෙන් දෙන්නේ ජෙනරල් කන්සෙප්ට් එකක්. හරි. ඊට පස්සේ අර ස්ටැබිලිටිස් එක ආපහු ඔක චේන්ජ් වෙනවා. ඒක ඔළුවේ තියාගන්න. අපිට ඔක්කොම මතක තියාගෙන ඉන්න බෑ සිලබස් එක කොහොමද ඔය 54 කිව්වට ඉච්චර ඉතින් අහන්නෙත් නෑ. එහෙම අමුතුවෙන් අහන්නේ මේවා කන්ෆිගරේෂන්ස් ලියන්නදී අර මේ දෙක තමයි කොමන් මේක. ඕක හොඳට ඔළුවේ තියාගන්න. පැලේඩියමුත් තියෙනවා මෙන්ෂන් කරලා. 54 කියලා තියෙනවා. හරි. මෙතකොට මම දැන් වෙනලාවක ඔකේ පෙන්නන්නම් මේවා ටික නිකන් දෙන්නම් මම නෝට් එක. හරි. මේ වෙනස්කම් තියෙනවා තව ඒ වගේ. හරි. ඒක ලොකුවට අර කතා කරන්නේ නැහැ. තියෙනවා කියලා නිකන් මතක තියාගන්න. නෝමල් විදිහට ලියන්න බෑ. මේවා විතරකුත් නෙමෙයි තියෙන්නේ. හරි. වෙන බහුභූත විදිහට යන්නේ. දාන්නකො in palladium in PD electron configuration should be කියලා මෙන්න මේක දාන්නකො. electron configuration should be this configuration but its actual configuration is this one KR4010 but its actual configuration is KR4010 KR4010 that means 5s electrons 5s electrons are not present 5s electrons are not present that means 5s electrons are not present 5s electrons are not present right this is a deviation of Aufbau principle දැන් මේවා deviations තමයි හරි kind of deviation හරි තව deviation තියෙනවා හිතා ගන්න බැරි deviation නේ පස්සේ ලොකුට ඉතින් කතා කරන්නේ නැහැ මම පෙන්නන්නම් මෙහෙම තියෙනවා කියලා this is a deviation of Aufbau principle next point this is a deviation of Aufbau principle next point reason for that fully filled 4D subshells offer greater stability compared to having both 5s and 4D then next week we have to discuss building of periodic table and then some patterns yeah it is that part and then we have to talk about there is a part electron configuration of ions right radius and few things and then last we can finish the lesson almost last week there might be a small part left at last week right we can finish it more than 90 around 95 right more than 90 we can finish last week right then this lesson is over last week means next week vacation right so you got a holiday right අපේ class vacations යනවා එතකොට after new year right after new year you will have classes, um, but your theory class in Saturday, right? It's not holiday, right? I mentioned it, right? It's not a holiday, right? So you don't get holiday for paper class, right? No vacation for paper class, right? Only this class. You got 2 days for this class, right? මොකක් හරින්ද දැන් පොයත් ඇතුණා අරකත් හම්බෙනවා right සාමාන්‍ය මෙම හම්බෙන්නේ නැහැ ඉතින් මුලනේ කමන්නේ නැත්තම් මන් දෙන්නෙත් නැහැ all right that's it so if you are watching I mean this then right nothing to say so let's meet on Sunday class right Sunday class එකේදී හම්බෙමු right so then up to then good night and so yeah that's it I mean if you have any questions then you can ask right I mean send a message and anything right okay then good night and see you later